This obviously hits home in Rhode Island because researchers at the University of Rhode Island have found these PBDEs throughout Narragansett Bay, with concentrations highest near Providence, where most of our population lives. And from Dr. Stapleton's testimony, it seems to be consistent with the national findings. She says that the Centers for Disease Control and Prevention have said that 99% of the U.S. population has flame retardant chemicals in their bodies. U.S. adults have body burdens that are an order of magnitude higher than levels in European and Asian countries, and that studies have shown that children clearly have much higher exposure and body burdens of flame retardants compared to adults. Could you tell me, Dr. Stapleton, take it back a step, why does a chemical bioaccumulate? Have we not developed processes as organisms for processing chemicals through our bodies?
Well, certainly we have enzymes or proteins in our body that are capable of metabolizing certain compounds. However, substantial data exists to show that there are certain chemical features that are resistant to metabolism. And in the case of PBDEs, those structures are clearly represented. They are very nonpolar, they are halogenated, they are quite large, they have what we call a high hydrophobicity factor, or log KOW, which leads to this bioaccumulation potential and resistance to metabolism in the body. Therefore, some of these PBDEs are estimated to have what we call a half-life, or the time it takes for the concentration of these compounds to decrease in the body by 50% of up to 7 years. So it takes a long time before the levels will drop.
And from a layman's point of view, or from a more general point of view, are new and man-made chemicals more likely to be difficult for the human body to process than ones that have been, ones that we've adapted to over years, generations of exposure?
Well, this is a little outside my area of expertise, as I am a chemist and not a toxicologist or a physiologist. But I can say that typically our bodies are not used to processing these chemicals for sure, and they can lead to more increased exposure or accumulation in our tissues. However, some of the chemicals, and PBDEs are a classic example of this, have a structure that's actually very similar to hormones in our body, which is what results in what we believe is responsible for their potential toxicity. PBDEs have a structure, chemical structure, that's very similar to thyroid hormones, for example, which is one of the reasons they are known to affect thyroid hormone regulation.
Now, when you were looking into your research, you've indicated that claims about confidential business information inhibited your ability to do the research that you're trying to do. Could you elaborate a little bit on what limitations you experienced?
Certainly. Well, with the growing evidence that the PBD concentrations were increasing in human tissues, many academic researchers were interested in conducting exposure studies or trying to identify the primary routes by which people are exposed and identify what the most common sources were in our homes, or to which we come in contact with on a daily basis. And unfortunately, these products, as I said, they're not labeled. And speaking with the Polyurethane Foam Manufacturer Association, for example, several of them have told me that sometimes they don't even know what chemicals they're putting into their products that they manufacture in terms of furniture. The only way we were able to determine what chemicals are actually used are found in products on the market today was by taking samples of those products and spending a lot of money and using very expensive equipment to analyze them in my laboratory. We found many of them to have proprietary chemicals, but with the technology today, we can determine what those structures are. Now we are beginning to assess exposure to those new chemicals and trying to determine what their potential health hazards may be.
So one could hypothesize that if one were concerned about a competitive business motive for protecting this information, it would be within the realm of most major corporations to be able to afford the kind of testing that you did. So they'd really have no problem being able to figure it out. It's independent testers who don't have access to that kind of money that are most disabled by the confidential business information claims.
Yes, that is correct. In this day and age, it's not that difficult to determine what the chemical structures are in all these different products.
So if a big company wanted to do what you did, they could do it pretty readily.
Yes.
But a researcher, it's a real handicap for.
Well, this is why we're doing this.
Yeah.
We're determining what their structures are so that we can determine what the levels are in indoor environments and what the levels or the exposure levels are for children, and then run some toxicity studies with them.
Mr. Moore, what dangers at what levels of exposure exist with respect to the flame retardants that Chemtura manufactures?
First, we manufacture a wide variety of flame retardants with respect to the ones that we are discussing today, Firemaster 550 and TBB within that. We've conducted over 30 studies for regulatory agencies as part of the pre-manufacturing notification and review of TBB. Those studies were reviewed, submitted to EPA and reviewed. 15 of those studies were required by EPA. The assessment of those found that the relative risk of those are extremely low and were acceptable for safe use in their application. I'd like to comment on your other question, if I may.
Well, let me try to get an answer to my first question. Does Chemtura concede any danger from these two flame retardants that you've identified?
Again, in terms of the expected exposures, in 2006, CPSC published expected exposures or predicted exposures of TBB, and those are much lower than any level that was predicted to have any sort of an effect. So in those terms, the answer to your question would be that no, those are
They're perfectly safe.
Mm-hmm.
Okay.